ordinary differential equation of the first order. Now we will solve a different equation and get the general equation. Let's try this example number 1. Problem number 1. We know that y prime is equal to dy over dx. Now we will substitute it with dy dx. Y times dy dx is equal to, you can factor x out by 2x times y plus 1. We will use a separable equation. We will let all y in left y over by multiplying the both sides by dx over d over y plus 1. We will get y plus 1 here, dy is equal to 2x dx. Now we will integrate both sides. By integrating this kind of equation, we will need to use we have to manipulate it by y over y plus 1. We have to add and minus both sides by 1 over y plus 1 minus 1 over y plus 1. It is just adding 0 on the equation. We will get the integral of y plus 1 minus 1 over y plus 1 dy. It's just like adding in the other side is 0, so you can write 2x dx. Now integrating this, you have to separate the other one like this, y plus 1 over y plus 1 minus 1 over y plus 1 dy is equal to integral of 2x dx. You can cancel this by 1, so the integral of that is y minus this one is ln. The integral of this 1 over y plus 1 dy is ln y plus 1 is equal to, the integrate of this is x squared plus the constant c. Now the general equation is this. The problem 2 is also finding the general equation. The first one is, I'd like to substitute y prime is equal to dy dx. X is equal to dy dx is equal to x cubed minus 2y. Now to get the differential form, you have to divide both sides by x over x, cancel, dy dx is equal to x squared minus minus 2 over x y. Can get dy over dx plus 2 of x xy is equal to x squared. Since we get that, we'll get the integrating factor. Integrating factor is equal to v is equal to e over integral of p of x dx. Since this one is the px of our differential form, dy dx is plus p of x y is equal to f of x. So v is equal to e integral of 2 over x dx is v is equal to e to ln of x. We can write this as transform this is equal to x squared. So we have to multiply it by x squared, the integrating factor, x squared, both sides. Now the equation will and also by multiplying this, we have to integrate both sides also. So we will get the y times x squared is equal to integration of x to the 4. The integral of that is y times x squared is equal to 1 over 5 x5 plus c. By getting y is equal to 1 over 5 x cubed plus c over x squared. Now this is the general solution of our problem, equation. The third problem is getting the general solution, general solution also, and we have the substitution. Since there's a u, we have to have a u in our equation, so we have to let u. You can transform this into dy dx is equal to, you can let u is equal to x plus y, and du is equal to dy. So this is du, sorry, and this is u times u minus 2. can also use separable equation here. All u is bring to this side du over u times u minus 2 is equal to dx, and integrate both sides. To integrate this, we have to use partial fraction. Partial fraction. 1 over u times u minus 2 is equal to a u plus b over u minus 2. You have to get a and b, so 1 is equal to a times u minus 2. Integrate, we have to get the 1, so we have to multiply it by u minus times u minus 2 plus b u. 1 is equal to a u minus 2a plus b u. 1 is equal to a plus b u plus this is minus 2a, then a plus b is equal to 0, and minus 2a is equal to 1. A is equal to negative 1/2, so we can get b is equal to positive 1/2. So the question now is you can substitute the 1 over u times u minus 2 by 1 over 2 u minus 2 minus 1 over 2 u. This integration of 1 over 2 u minus 2 minus 1 over 2 u by dy is equal to dx. The answer the integration by integrating it, you can get 2 1/2 of ln of u minus 2 minus 1/2 ln of u is equal to x. We can manipulate it and we will get, by manipulating it, 1/2 ln of u minus 2 over u is equal to x plus c. Now since we can say that this is the general equation, we can substitute u is equal to 1 minus x. By substituting it, ln of u is, you can get negative x plus 2 over, since u negative x minus 1 x plus c. Cancel the negatives and you can get ln of x, oh sorry, this is 1, x plus 1 over x minus 1 and is equal to x plus c. Now we get the general equation. The fourth problem is show that the product of homogeneous function of degree m and a homogeneous function of degree n is a homogeneous function of degree m plus n. We can assume that m of x is a function of as a homogeneous function that equals to 2x squared plus 2y squared, and to get the degree of that is we have to change m x x t, the substitution x is equal to xt and y is equal to yt. So we'll get 2x squared by t squared plus 2 y squared t squared. By simplifying it, you can get out that t squared times 2x squared plus 2y squared. So this is the function of m of yours. So you can get t squared times the function of l, x, y, x by function of m. We can say that the degree of this is 2, so you can assume that m of this t can be m of x of t y t is equal to t m function times function of x y, the same as the other function yt that you can raise it to the degree of n of m of x times y. So show that the product of the homogeneous function of degree m and the homogeneous function of degree n is a homogeneous function of degree m plus n. You can write this as m x t y t times n x t y t. Since t is equal to m function of x y times t is n function of n x y. By multiplying it, we can get that t m plus n is a function of that the two product of two function, and we can assume that equal function is equal to f of x of y, function of x and y. So we, now we show that the degree of the product of two degree homogeneous function, the degree m and n is equal to degree of m plus n.